Why do we feel pain and what does it mean? Most people think about pain as a simple cause and effect process. For example, if you touch a hot stove, you probably assume that the nerves in the skin feel how hot the stove is, and signals are sent to the brain to trigger a feeling of pain. Research shows, though, that the pain signaling, as well as the sensation of the body perceives as pain, can be more complex than this scenario. Pain is hardwired as a social alarm of a threat, which is then selected over the competing demands and triggers behaviors that interfere with normal life functioning. Pain is a normal sensory signal that something might be wrong and that you should do something about it. You don't become aware of pain until your brain processes it. In fact, there are many different types of pain, and you may be aware that the different types of pain are classified into specific categories. Visceral pain is a type of pain that occurs when the internal organs are damaged or sick. It can be difficult to know which organ is causing the pain because internal organs have different pain pathways than the outside of your body does. Neuropathic pain. This pain occurs when your nerves aren't functioning correctly. It might feel electric and you might experience extreme sensitivity to touch and temperature. Nociplastic pain. This type of pain is one of the potential end results of nociceptive pain that lasts for a long time. In cases of chronic pain conditions like fibromyalgia and recurring tension headaches, a person might have a persistent pain even if the body doesn't show any signs of damage. Nociceptive pain is a discomfort you feel after an injury or damage to your body's tissues. You might feel sensations like aching, burning, cramping, stabbing, and throbbing. In the context of phantom limb pain, it is the perception of pain or discomfort in a limb that is no longer there. Imagine you lost your left hand, but you can still feel it, itching or hurting. This happens because the nerves in the amputated area send signals to your brain, which interprets them as coming from the missing limb. It's like your brain has a map of your body, and even though your limb is gone, the map doesn't update immediately. How do we know that we are in pain? The experience of pain is known to have two distinct neural pathways. In the first pathway, the pain signal comes from any part of the body and activates the anterior cingulate cortex of the brain, which is associated with the perception of pain. People react differently to the stimulation because the feeling is determined by the activation of the second pathway involving the medial prefrontal cortex and nucleus accumbens, which are associated with motivation and emotion. Further, there are non-physiological factors that contribute to the perception of pain. What is the gate control theory of pain? We mentioned a while ago about pathways that connects our nerves, which transmit signals to our brain when we get hurt. It is as if that there are gates in our body that enables the transmission of signals through our mind. The gate control theory of pain explains that the spinal nerves act as a gate to let pain travel through to reach the brain. Or close, these gates prevent pain messages from getting through at all. For example, let's say you accidentally touch a hot stove. Your hand sent a pain signal through your nerves to your spinal cord and up to your brain. Now, let us imagine you immediately shake your hand or put it under a cold water. These actions sends a non-painful signals to your spinal cord. In the spinal cord, there are gates that can either allow the pain signals to reach your brain or block them. The non-painful signals from shaking your hand or cooling it down can also help close the gate, reducing the amount of pain signal that gets through the brain. As a result, you feel less pain because of the fewer pain signals are making in to your brain. Have you ever heard of dopamine? Dopamine is known as a feel-good hormone. It gives you a sense of pleasure, and it also gives you the motivation to do something when you're feeling pleasure. Endorphins and dopamine are both chemicals in your body that makes you happy, but they function in different ways. Endorphins relieve pain naturally when they attach to your brain rewards centers, opiate receptors, and dopamine is then released. Sense of smell. The olfactory system is responsible for our sense of smell. These scents are also known as the olfaction. It is one of our main senses and it involves the detection and identification of molecules in the air. Once detected by sensory organs, nerve signals are sent to the brain where the signals are processed. Our sense of smell is closely linked into our sense of taste, as they both rely on the perception of molecules. It is our sense of smell that allows us to detect the flavors in the foods we eat. Our sense of smell can ignite memories as well as influence our food and behavior. Sense of taste. Gustation is the special sense associated with the tongue. The surface of the tongue, along with the rest of the oral cavity, is lined by the stratified squamous epithelium. Raised bombs called papillae contains the structures for the gustatory transduction. There are 4 types of papillae: circumvallate, foliate, filiform, and fungiform. Within the structure of the papillae are taste buds that contains specialized gustatory receptor cells for the transduction of taste stimuli. These receptor cells are sensitive to the chemical contained within food that are ingested, and they release neurotransmitters based on the amount of the chemical in the food.